Hello students, welcome to the physics class. So in this chapter we are going to study the magnetic effect of the electric current. So far we have studied about the heating effect of the electric current, in which we studied that when current passes from the conductor it produces heat due to various factors that we have done. So similarly, if I tell you that also electric current can produce a magnetic field, yes, it is the electric current. When it passes from the conductor, it also produces magnetic effect around the conductor. It means हम किसी भी substance which is a good conductor, if we pass electricity from that conductor, we can make it as a टेम्पररी मैग्नेट की तरह हम उसको यूज़ कर सकते हैं. इफ़ वी आर नॉट हैविंग अ मैग्नेट, हमारे पास कोई परमानेंट मैग्नेट नहीं है, तो वी कैन यूज़ द कंडक्टर एंड बाय पासिंग करंट फ्रॉम दैट कंडक्टर वी कैन मेक इट एज अ मैग्नेट. यस, सो let us explore about more about the magnetism first, and after that we will proceed to the concept. Clear? So magnetism was discovered 2500 years ago. Earlier magnets were made from naturally occurring substances. Lodestone जो कि आयरन की ओर है, which is a black ore of iron. From there it was extracted and it is also known as a magnetite. Right? Clear? सो बट जो नेचुरली हमें मैग्नेटाइट मिलता था उसमें जो मैग्नेटिक प्रॉपर्टीज़ होती हैं दोज आर वेरी वीक प्रॉपर्टीज़. सो जो मैग्नेट्स हैं देवर आफ्टर रिफाइनिंग दैम दे वर मेड proper working strong magnets were made. Even artificial magnets are also used. Artificial magnets you might be seeing in our daily life also, like doors के जो knobs होते हैं उनके पीछे लगे होते हैं to keep a door closed or opened, right? It is also used in the compass needles. Maybe जो needle होती है, it is a magnetic, it is a small magnet, right? So there are various properties. So now let us proceed to the properties of the magnets. One is that magnet attracts the materials such as irons, cobalt, nickel. कुछ materials हैं जिनको iron, जिनको जो magnet है it attracts itself. And one more thing student, the attraction is the maximum at the poles. Means जो magnetic properties, magnetic effect होता है एक natural जो magnet होती है सबसे ज़्यादा effect उसका is at the poles, whereas the less effect is in between the magnet, right? And when a bar magnet is suspended freely in the air by using a thread in the center, in the middle, it will always align itself in the north south direction. What is the reason? Means जो जब हम इसको सस्पेंड करते हैं फ्रीली, वो अपने आप को नॉर्थ साउथ डायरेक्शन में अलाइन कर लेती है. व्हाट इज़ द रीज़न? आई विल टेल यू इन द नेक्स्ट सेशन. नेक्स्ट इज व्हेन टू मैग्नेट्स आर ब्रॉट क्लोजर टू ईच अदर लाइक पोल्स repel each other, means north and north pole or a south and south pole repel each other, whereas unlike poles like north and south pole they attract each other, right? So these are some basic properties of naturally occurring magnet. Clear? So let us proceed to the process to the concept of magnetic field. What is the magnetic field? Like we say this is the electric field. Electric field word हम बहुत बार यूज़ कर चुके हैं, तो this is the new word magnetic field. So you might be, आपके मन में तो ये बन तो गया होगा that magnetic field is something the space around the magnet. ऐसा ही कुछ होगा, magnetic field का भी कुछ ऐसा ही concept होगा, right? So yes, the space around the magnet, which is around the magnet, जो space होती है जहाँ पे there is attraction और repulsion का zone होता है magnet का, that zone or that space is known as the magnetic field of the magnet. So it is the space around the magnet which attracts or repels the substances which are attracted by the magnet. So जो area space around the magnet होता है which influences the force, जो force apply करता है, चाहे वो repel कर रहा है चाहे वो अट्रैक्ट कर रहा है। तो मैग्नेटिक फोर्स जहाँ जहाँ तक स्पेस में प्रेजेंट होती है अराउंड द बार मैग्नेट, सो दैट इज़ द मैग्नेटिक फील्ड। ज़रूरी नहीं है कि बार मैग्नेट का ही मैग्नेटिक फील्ड होता है, इट कुड बी ऑफ द आर्टिफिशियल मैग्नेट ऑल्सो, जो हम बनाते हैं बाय पासिंग द इलेक्ट्रिक करंट, उसके भी अराउंड मैग्नेटिक फील्ड होता है। मीन्स एक पर्टिकुलर लिमिटेड स्पेस होती है अराउंड द मैग्नेट, सो दैट इज़ द मैग्नेटिक फील्ड। यू कैन टेक एन एग्जाम्पल, like there is a nail, you can see this is the dotted line is the magnetic field area, after that there is no magnetic field, right? So you can see the iron nail do not get attracted because it is outside from the zone of attraction of the magnet, that is it is outside from the magnetic field zone, right? So when it is brought inside the attraction zone, so it gets attracted towards the magnet. So this is how the magnetic field influences the materials. Clear? Next is a short activity to find out that the force, the जो बार मैग्नेट है, the जो बार मैग्नेट होता है उस पे we can also find out the attraction that it is more at the poles by using iron fillings. We will do it as a practical also. हम एक तरह की activity I will perform and I will show you that how do this occurs. This shows that iron fillings are more attracted at the poles, whereas they are not as much attracted at the in the center of the bar magnet. And you might be seeing there is a pattern, it is a zigzag pattern is there, zigzag, the circular curved lines, uniform lines are there, not a zigzag. You might be these are appearing like this, है ना? So this also depicts the magnetic field lines. Magnetic field lines are the imaginary lines that we assume that they flow in this pattern. Even we have shown it in this activity, it is also visible that this is a kind of magnetic field which is present in this pattern, right? So we conclude that the magnetic field lines are the lines which represents the zone of magnetic field, and it represents the direction of the magnetic field. So how can we find out the shape of magnetic field lines? That they always travel in the curved path, curved loop की form में. Loop means which is continuous. So how do we find out? That is done by using the magnetic compass. A magnetic compass को use करके we can find out the shape of magnetic field lines, that in which shape they travel. So for that you need a compass, a magnetic compass and a bar magnet. So keep it, try to keep it in the zone of the magnet. So you will see that the needle gets deflected in a circular path. थोड़ा थोड़ा जो पोजीशन चेंज करते जाओगे, A to B position, C, D, E, F, G, H, तो you will see that the needle will also show a circular path around the magnet. Not circular path around the magnet nahi, from north pole to south pole it will form a complete circle. Clear? So this is how the magnetic field lines move around the magnet. और उससे हमें डायरेक्शन भी पता चल रही है. You can see the arrow is pointing from north pole towards the south pole. So इससे we can also conclude that magnetic field lines की direction is from north pole to the south pole, and from inside the magnet south pole to north pole होती है inside the magnet, whereas outside the magnet it is from the north pole to the south pole. Yes. So I think you have you are clear with this. Next comes an important topic which also usually comes in exams in 2 or 3 marks, like properties of magnetic field lines. What are the properties of magnetic field lines? What are the things which differentiate from the basic magnet जो इलेक्ट्रिक फील्ड होता है या फिर बाकी जो हम रिप्रेजेंट करने के लिए लाइंस वी यूज़, हाउ डू दे डिफरेंशिएट फ्रॉम द अदर्स? फर्स्ट थिंग इज स्टूडेंट्स दैट दे आर ऑलवेज इन द क्लोज्ड पाथ. If you are able to see the bar magnet, so you will look like they are in the closed circular path. They never end, means they always form a loop. they keep on moving from north pole. They come out from a bar magnet at the north pole and enter the bar magnet at the south pole, right? So this is the direction. So they are always in the closed continuous curve that never ends. Clear? And also they are imaginary lines. Actual में we cannot see them, they are virtual means we have an imagination जिससे हम patterns draw करके we find out that the magnetic field lines are like this. So actual में we cannot see the magnetic field lines, we can just feel their strength by using a magnet, by using iron piece or any kind of the substance that can be attracted by the magnets, right? So next is the tangent at any point of the magnetic field lines give the direction of magnetic field at that point. Means if we draw a tangent you might be knowing that it is the line which is drawn from any point of the circle के किसी point से जो हम straight line draw करते हैं, that gives us the tangent. So this is the how we draw the tangent by taking one point. So it always tells us the direction. So means it is always in a single direction. The tangent at a point of the magnetic field gives the direction of the magnetic field at that point. Yes, we need to know that what is the direction at this point. So it will always point towards this side. At this point it is in this side, from here it is this side. So it always gives us a particular direction. This was also shown by the magnetic compass needle direction, how we can find out the direction. That was done by the magnetic compass needle also, right? So next is the magnetic field lines are close together at the magnetic field lines are closer together in the region where magnetic field is strong. We know that magnet के अंदर तो बहुत ज़्यादा strong होगा ना magnetic field. So you can see magnet के अंदर बहुत ज़्यादा closer है एक दूसरे के पास. So which makes the strength, जिसकी वजह से जो magnet है उसका magnetic field ज़्यादा होता है as inside the magnet, right, as compared to the outside. And the magnetic field lines do not intersect each other. Means ऐसे नहीं है कि they would overlap each other या फिर they are intersecting, cutting each other, right, like this. They never move from one another. So they always pass from the bar magnet or from the even in the around the magnetic field बाहर वाला जो space है उसमें भी they never intersect. Because if they will intersect, let us take an example. If they intersect at a point, right, तो हम suppose कर लेते हैं that this is a magnetic field line and this is also a magnetic field line. So if we draw a tangent from here, we will get the curve. इस curve की direction will be in this side and इस curve की direction will be in this side. So but we know that magnetic field lines की तो एक ही direction होती है, but tangent if we draw like this, it gives us two directions. So this is a contradictory situation. So it means they never intersect each other, because if they intersect each other they would give us two directions. ऐसे कभी नहीं होता है. So this could be the question also, that how will you prove that the magnetic field lines do not intersect each other? So you need to draw this diagram to prove that, and you will say that this is the reason due to which magnetic field lines never cross each other or intersect each other. Clear? Let us take an here also. There is a misconception that the direction of magnetic field is always from north pole to south pole, right? So but the direction of magnetic field is from north pole to south pole outside the magnet. Magnet के बाहर ये confuse नहीं हो जाना है, because बाहर magnet के बाहर तो the direction होती है magnetic field lines की, that is from the north to south pole, whereas inside the bar magnet it is from south pole to the north pole, right? So this is practice exercise. This we will discuss in the session of Zoom class, right? So next comes the magnetic effect of the current. That is our chapter तो यहाँ से इट इज़ द बेस, जो हमारा चैप्टर है वो स्टार्ट होता है। बट ऐसे नहीं है कि यू विल लीव दिस इज़ एज मच एज इम्पॉर्टेंट एज वी आर स्टार्टिंग नाउ हियर। So you need to watch another video for this topic. Thanks.